Hey everyone, so today we are live in period 3, Honors Algebra 2. We're just continuing on to the notes. Today we're talking about how to write a piecewise function based off of the graph. I'm going to do the first one here for you just so you're kind of seeing what's going on, and then after that I'm going to have you try one on your own. One of the big things about doing these types of piecewise functions and writing them is you have to know that anytime you have something that looks like it's a sharp movement, it means that it's going to be a break. So what I mean here is I've got there, obviously, or it's not super obvious, but I have two different equations that I'm going to have to draw. I've got a break in between here, so these are also going to be two different equations. So essentially I have 1, 2, 3 parts, or 3 equations that I'm going to have to write. So I'm going to write out my f of x. Okay. If yours doesn't look as elegant, that's okay. I just need to make sure that I can see what's going on. And I'm going to look at this first part here that I put in orange. If you notice, this is a horizontal line. Horizontal lines always have a slope of 0. So this would be technically y is equal to, it looks like 3. So what I'm going to do here is I'm just going to put a 3. Now here's where it becomes a your choice type of situation. Because we broke on something that was closed, you're either going to make one inequality and a closed, or and one an open, or one an open and one a closed. It'll be up to you as to what you want to decide. So for example, this is true for all values where x is less than -4, but because that's a closed circle, I could technically say that that's x is less than or equal to -4. Because my next one's going to start, because they connect, -4 is less than x, so you could either put the equals up top, or you could put it down below because they're connected. You see what I mean? Like I can't distinguish between which one was the closed circle and which one was the open circle, because it goes back to that whole, like, it fits like a Lego piece, one and the other. So I don't know which Lego piece is fitting in, so I can choose which one's equal or which one is just the less than or greater than. Yeah. Is it -3?
Where did you get to the 4?
I got the...
Cam Corio, please report to room AA217. Cam Corio.
Oh, I got the 4 from 1, 2, 3, 4. It's -4, and we're looking at the x value for whatever it comes to the inequality. So whenever I'm doing this, I just need to decide whether that's going to be a less than or equal to, or I can flip-flop them. Let me put it this way: is if you flip them, you're not wrong. Okay, which is fine. My other inequality, though, is not just from -4 is less than or equal to x, though. It's over until it gets to -2, which you can see here. See how it goes to -2. Now that is an open circle, so that has to be less than 2, or -2. Sorry. Now, how you'll find an equation based on what you actually have as a line. Is fairly simple, but it takes a little bit of algebraic skills to kind of remember and refresh. So the first thing that I'm going to do is I'm going to find the slope between the first and the last point. So if I'm looking here, 1, 2, 3, 4, 5. So I went down -5 and then go right 2. So -5 halves x. That's the first part of my equation. Now in order to find the next part of my equation, though, let me draw the x. I'm going to have to, because I don't know where it crosses my y-intercept, I'm going to have to use one of those points and create the equation of the line. So I'm going to use the point that's included here. So if I look at this point, this is -4, 3, and I'm going to use the slope. So I've got a slope that's -5/2. I've got the point -4, 3, And I'm going to use y minus y1 is equal to m times x minus x1. You don't have to use that. That's called point slope. You could just find your b value. But I'm going to plug it in here. Y minus 3 is equal to negative 5 halves times x plus 4. So y minus 3 is equal to negative 5 halves x. Let's see here. The 4 and the 2 will divide, so it'll be minus 10. And then y is equal to negative 5 halves x minus 7. So right there, that minus 7, that'll be the rest of the equation. And then that'll give me that part of the equation for that example. That way we're not doing any guesswork as to where it crosses the y-axis. I've got one more. I'll do this one in green. Okay, I'm looking at this line here. This line starts at negative 1, and it's closed circle, so x is greater than or equal to negative 1. The slope, 1, 1, 2, 3, 4. The slope is 1/4 x. And then I'm going to pick that point of negative 1 comma 0. So I've got the slope of 1/4. The point negative 1 comma 0, and I'm just going to plug that into my equation there. 1 minus 0 equals 1/4 times x plus 1. So y is equal to 1/4 x plus 1/4. So again, I don't have to worry about any of the guesswork as to determining where my y-intercept would lie for those types of problems. Okay, so that would be how I would write my piecewise functions. Okay. Questions at all? Yeah.
I'm confused with how you got negative 4 is less than or equal to.
So as I said before, you could have it doesn't matter if you have, well, that really. So this less than. This could have also been an equal up here because of where it's at. You get to choose which one the equals goes to because it's a closed circle where they connect.
Yeah. And so why did you put that x is less than negative 2?
Because that's where I am on my x's, on my x values. I'm not looking at it as diagonal. I'm looking at it horizontally. Let me do this in red so you can kind of see. I'm going from negative 4 all the way over to negative 2. I'm looking at it as an x value wise because it's a domain restriction, part of your domain. Okay. All right. I'd like you to try the next one. Try the next one on your own. I'm going to leave the recording on so I can finish it up. If you're at home watching this again, this is a great time to pause your video. Okay. Yeah.
Can you zoom in on your graph? We can't see our line.
Yeah. You know, do you want me to put the coordinate points on for you? Would it be easier?
Yes.
There you go.
So the way that we want to have this, and so that's good. So then the next part is you want to find out what the slope of this line's going to be. And then once you once you find out what the slope is, pick one of the points on here. I pick this one because it's close. And use y, use point slope, or use like y equals mx plus b to find out what your b value is going to be. Once you have that, then you can that'll create your equation of your y.
So would the b? So then would it be your slope and then your b value?
It'd be slope x plus b value.
So you're writing this in the y.
Yes.
Y
Like
slope
y equals. Yes.
and then you're using it to, and then you fragment. You solve for the slope.
Find the slope, solve the b value, and then once you have that, then you can just use your domain restriction. Your domain restriction should be the easiest part. Yeah, once I'm done with the
Okay.
sorry.
So why can't you just write greater than? This is like.
This would say x is greater than or equal to -1. So that means that you have everything on this line, it would be over this way, which isn't true. This, when you turn this around, it makes it so the x is less than -1. So it's between, it's greater than -5, but less than -1. So you get to change that.
Yeah, but these ones overlap in
But they're all different equations. That's why you have to have a pieced out by equation.
All right, so if you're taking a look at what I've got on here so far, I just did the first two. The first one, you have a slope of 0, so it's y is equal to -2. The next one, you have to find the slope, so I went up 6 and to the right 4, and I got, so 6 over 4, which is 3 halves. And then I chose the point -1, 4. I plugged it into point slope, and then I found that my b value is 11/2. So 3/2 x plus 11/2. -5 is less than x, so x is greater than -5, but it has to be less than or equal to -1. So right now, if you're kind of following along, I'm on this line here. I'm going to do the same exact thing that I was doing. I'm going to find my slope. So 1, 2, 3, 4, 5, 6. So I went down 6, went over 4. So that's going to be, in this case, it's -3/2. And then I'm going to pick a point because it's 3/2.
This is Constance. Please call station 2.
It lands perfect on 1, 0 as well. So I'm going to use that. So y minus 0 is equal to -3/2 times x minus 1. So y is equal to -3/2 x plus 3/2. And then it looks like it goes from -1 to 3, and they're both open circles. So -1 less than x, which is less than 3. I gotta move my work for this because I don't think I'm gonna have enough space for where I'm at. So I'm just gonna throw it over here to the side for now. On my last one that I have, I'll do that in green. It's this equation or this line here. And I'm doing the same exact thing again. I'm just going to go from these 2 points, 1, 2, 1, 2, 3, so -2/3. And then I'm going to choose any of those points. I'm going to use 3, 3. So y minus 3 is equal to -2/3 times x minus 3. So y minus 3 is equal to -2/3 x plus 2. So y is equal to -2/3 x plus 5. And then it has to be where x is greater than or equal, it looks like, to 3. So this would be my final answer for solving that out, for writing the equation. Yeah. So for the second one, the one that's in orange, you're looking at it. Let me erase some of this here so you can kind of see. You're looking at it from here all the way over to here. This has an open circle. This has a closed circle. So that's how I ended up with the greater than or equal to for that one. Any other questions before we move? I've just got 2 more things I want to show you. Yep. Can you say that a little bit louder? Yeah. So looking at this green part here, let me erase some of this stuff here. I start at 3 here. This is a closed circle. And then it's everything afterwards. So it'd have to be greater than or equal to. Right. All right. So one of the last 2 things that we're going to talk about today are step functions and then absolute value functions, which you've seen absolute value before. Step function is something that's a little bit different. So the way that the step function works is it's a piecewise function that consists of different constant range values for different intervals of your domain of the function. So think of it as, in life, and more particular with this, what we call the greatest integer function. In life, if you're told that you got a decimal of 2.7, round up, in this case, no matter how the decimal is, you always round down. So instead of you got the number 2.7, instead of going to 3, you're just going to drop back to 2. Okay, and I'll show you why here. The greatest integer function or the round down function, as it can be called, it'll be denoted by a double bracketed x. And the graph itself, I want to show you this graph because this is kind of cool. This is why it's called a step function. It starts out where you have your first whole number that's included, and then as soon as you get to your next whole number, it jumps up. So it looks like a set of steps. There's no in-between decimals. There are different variations of this, but this is the only one that you guys really need to know, or at least be cognizant of. So, for example, if I were to look at where -3 is, -3, I'd be at -3. Okay. -1.5. I'd be at -2, so I rounded down. At 0, I'm at 0, and even at 2.99999, okay, I still round down to 2. This makes it so the domain is always all real numbers. But the range is just the set of integers. Okay. So here's an example that I want to show you. Say, for instance, I said solve -3.4 plus 1. You always round down no matter what the decimal. So -3.4 is really -4, because on a number line, down the least would be -4, plus 1, which would be -3. Okay. Solving it, you will not have to know the graph right now. It's just solving. Solving is the big thing, is whenever you see it in that. Okay. So, I mean, if you wanted another example, if I said solve 1.7 step function -3, this would just be 1 minus 3, which is -2, because you always round down. And then the last thing that I want to show you, especially for this video, is the absolute value function. Now, I don't remember some of the stuff that goes in here, I'll be honest with you. Absolute, and I don't think you really need to know it. Here's the absolute value, big thing you need to know, and you've seen it before. It's got absolute value symbols. Domain is -infinity to positive infinity, and the range is based on the location. Okay. It's a V-shaped graph. And it's very easy to find out what that graph is. Just plug in some X and Y values. They all turn positive when you plug them into a standard graph. Now, depending on what else is in your graph, they might change direction or change different course, but that's pretty much it.